Today, we are diving into something called decentralized science, or DeSci for short. And its goal, well, it's nothing short of completely rebuilding how science gets done for the internet age. We're talking more open, more transparent, and way more collaborative. But to really get why this is so necessary, we have to start with a fact that is, well, it's pretty darn alarming. So what's with this number? Get ready for this. According to a recent study, more than a quarter, 1 in 4, of all scholarly articles are at risk of just poof, disappearing from the internet. It's a thing called digital decay, and it means our collective knowledge is literally eroding away while we're not looking. And this digital decay, it's really just a symptom of much, much bigger problems. You see, traditional science is kind of stuck. A handful of giant publishers call all the shots. It's hard to see where the money for research actually comes from. So much knowledge is locked behind crazy expensive paywalls. And data is just tucked away in separate silos, which makes teamwork almost impossible. And that is the system DeSci is aiming to blow wide open. So here's how we're going to break it all down. We've touched on the crisis. Next, we'll zoom right in on a core DeSci solution, publishing research on the blockchain. Then we're going to look at the blueprint for how these new kinds of organizations actually run themselves. And finally, we'll zoom back out to see the big picture, the incredible promise, the real progress, and, yeah, the very serious perils of this whole new frontier. All right, let's get into the nitty-gritty. How does any of this stuff actually work in the real world? We're going to start with one of the most fundamental parts of science, getting research published and making sure it sticks around. So this really begs the question, right? If our current setup lets a quarter of our knowledge just vanish into thin air, how do we build something better? Something that's permanent, that anyone can get to, and that's kept safe for, well, forever. The answer, according to the folks in DeSci, isn't just a new policy, it's a whole new tech stack. Okay, so check this out. This is a real-world example from a platform called preprints.io. And yeah, I know, it looks a little complicated at first glance, but stick with me. This diagram shows the journey a single research paper takes. It starts off as a simple manuscript and, using some really cool tech, gets transformed into a permanent, verifiable asset that lives on the blockchain. Let's break down what's actually happening here. Let's boil that whole process down to 4 basic steps. First, a researcher submits their paper. But instead of it going to some publisher's private server, it gets sent to a decentralized storage network. Then it's minted as a unique digital asset on the blockchain, which creates this unbreakable record of its existence. And finally, this digital asset can be shared and accessed by anyone, anywhere. So let's talk about those 2 key pieces of tech. So that first piece of the puzzle is something called IPFS, or the Interplanetary File System. The easiest way to think about it is like a giant public hard drive for the entire world. Instead of a file living in one spot on one company's server, it gets broken up and stored on a whole network of computers. This makes it insanely resilient. You can't just delete it. You can't censor it. It's a direct solution to that whole disappearing research problem. And the second piece is the NFT, the non-fungible token. Now, I know what you're thinking, but forget about a picture of an ape for a second. In science, an NFT is more like a digital certificate of authenticity. It's a public, totally verifiable proof that says, hey, this person created this piece of research at this exact time. It can even be used to manage the intellectual property, creating a totally transparent and open marketplace for new ideas. Okay, so we've seen how a single action, like publishing a paper, can be decentralized. But that just leads to a way bigger question, right? If you kick out the publishers, the university departments, the old school hierarchies, who's actually running the show? And that right there is the million-dollar question for DeSci. Without a CEO, without a board of directors, how do you make decisions? How do you hand out funding? How do you steer the ship and make sure it doesn't just descend into total chaos? The answer means we have to completely rethink what an organization even is. This slide just lays it out so perfectly. On the left, you've got the classic corporate pyramid we all know. The big ideas come from the top, and the work gets done down at the bottom. But on the right, that's the new model that's popping up in DeSci. It's called the Decentralized Science Pyramid Framework, and it literally flips that old structure on its head. The big idea here is so simple, but it's totally radical. Just flip the pyramid. Instead of strategy flowing down from a tiny group at the top, the entire foundation of the whole thing is the community of people actually doing the work. The thinking here is that science has always been a bottom-up thing, right? It's driven by discovery in the lab, not by some directive from a boardroom. And I absolutely love this quote because it just nails it. The community, the researchers, the coders, the contributors, they aren't just involved in the organization. They are the organization. They're the operating core. They are the engine that makes everything go. So you're probably wondering, how does a massive global community actually get anything done without bosses? Well, that's where these middle layers come in. You've got the technology, the code that automatically enforces the rules so you don't need a middleman. You have new organizational structures like flexible teams and DAOs that can form to tackle specific problems. And most importantly, you have governance, where community members use tokens to vote on everything, from which projects get funding to changing the rules of the game itself. And all of that, the community, the tech, the governance, it's all in service of what's at the very top of the pyramid, the application. This is the whole point. It's the actual, tangible, scientific result, a new breakthrough drug, an open-source medical device, a huge shared data set for the world to use. That's what this entire bottom-up structure is built to create. Okay, time to pull the lens back one last time. We've looked at the how and the who. Now let's talk about the what, and more importantly, the what if. What's the massive promise of DeSci? What kind of progress have we already seen? And what are the serious risks we have to face? And listen, this isn't some far-off sci-fi dream. It is happening right now. You've got groups like VitaDAO, where the community votes to fund research into living longer. You have Molecule and LabDAO, creating open markets for biotech ideas, and even building networks of community-owned labs. The ecosystem is alive, and it's growing fast. But, and you knew there was a but coming, this incredible progress has a shadow. This quote from Barry DeVries is a real gut punch. It's a stark, and honestly, pretty terrifying warning. The very same open, powerful technologies that could help us cure diseases could also be used by someone with bad intentions to design new and more dangerous biological weapons. And this is where we get to the heart of the problem. It's a classic double-edged sword. On one hand, the opportunity is incredible. AI can help us discover drugs faster than we ever thought possible. But that same AI could be used to create new bioweapons. Decentralized labs make science accessible to more people, but that also makes them incredibly hard to keep an eye on. Making science more democratic is a beautiful goal, but it also means the tools could fall into the wrong hands. When you boil it all down, it comes to this. The technologies at the very core of this DeSci revolution, AI, synthetic biology, automation, they are all dual use. Their power for good is matched only by their potential for harm, and that forces us to try and find a very difficult balance between scientific freedom and global security. Which leaves us with the one question that matters most. The whole mission of DeSci is to unlock our potential by making science radically open to everyone. But as we throw those doors wide open, how do we make sure we're ready for whatever or whoever might come through them? How do we build a future that accelerates progress without accidentally unleashing unimaginable peril? That's the challenge that's going to define the future of science.